All right, let's do some easy physics together. On the figure shown, all four charges are plus q, minus q, and situated at the corners. Net electric field, or net electric force on each charge, big Q, is 0. All right, so what they're saying is you got two positives, two negatives. They're different magnitudes, though. All right, but the force on big Q is 0. So I'm gonna just put F equals 0 for them. All right, express the magnitude of little q in terms of big Q. Okay, not too bad. So let's just think about this top guy right here. So we're going to figure out where its forces are. So we're going to add up its three forces. There's three forces acting on it. Force number one is an attraction force going this way. Force number two is an attraction force going that way. And force number three is an attraction or a repulsion force going this way. Okay. So here's the dealio. This is a square, right? Yep, square. So these sides are all equal to each other. So what we're gonna do is we're gonna break it apart into its components. This diagonal one here. Okay. So this guy here is gonna be some force. We'll call it force 1. We'll call it these guys force 2. They're gonna be equal, so I'll just call them force 2. So what I do know is that this is a 45-degree triangle. So that means these sides right here are going to be root 2 over 2 F1. Now I know root 2 over 2 F1 is equal to F2 for either one of those sides. So that's how we're going to tie them together. So let's just write F2 is equal to root 2 over 2 F1. So now we're going to use Coulomb's law and break down these F2s. Okay, so F2 is going to equal K times big Q little q over R squared. All right? So let's just call this R. Right? We can pick whatever letter we want. I'm just going to leave it as R. Now that's going to equal root 2 over 2 times F1. So F1 is going to do the same formula. K Q times Q, let's just write Q squared, divided by the distance. What is this distance going to be? It's going to be R times the square root of 2, right? Same idea, just run it in reverse here. And that's squared. So now we just have to solve for little q here. So we're solving for that. Before we get too far into it, let's try to take out as much as we can. We've got a k on each side, bada bing, bada boom. You've got an r squared over here. You've got an r squared here after we distribute those squares. So let's distribute the squares and then cross out r's. And that looks to be about it. So we're going to divide by q. Well, divide by big Q. So that takes out one of those. All right, let's see where we're standing after that. Little q is equal to, that's going to be a 2. Root 2 squared is going to be 2. Combined with there is root 2 over 4 times q. And that's all that's left, right? Nice. Just a bunch of algebra, really. Easy money. Let's do the next one. Is the net electric force on each charge negative q also equal to 0? Justify your answer. Well, let's figure it out. I'm just going to grab this one. Doesn't matter which one, they're the same. There are 3 charges on there. One charge is going to be attraction force going this way, one charge is going to be attraction force going this way, and one charge is going to be a repulsion force going that way from the other negative q. So we're going to do the same thought process here to figure out if they are 0. So we're going to break apart this middle one into its component forms. Let's see, 1 and 2 are taken. I'll call this F3, and this one will be F4. This one is also F4 because they're the same. So F3, this is going to be root 2 over 2 F3. So we are going to add f3 root 2 over 2 f3 and f4 and see if they're equal to it, see if it equals 0. Okay. Because they should cancel out, right? If, well, if they're 0. I'm willing to bet they're probably not, but hey, I haven't done this yet. So f4 plus root 2 over 2 f3 equals 0 question mark. Let's find out. So f4 is between the two of them here. So you're going to have k times big Q, little q over r squared. Let's just leave it as r. Worked well last time. Worked well enough, at least. And then over here, we're going to have root 2 over 2 times f3. So f3 is going to be little q squared divided by r squared. Well, the radius for here is going to be, just like before, the root 2r squared. Root 2r, then square. And we're going to see if this is equal to 0. Okay, things we can do. We can multiply. Oh, I forgot the k. I mean, the k cancels out, right? So we can divide everything by k. Divide by k for f4, k goes away. Divide by k, f3, k goes away. Divide 0 by k, k goes away. Same kind of thing for r squareds, just like before. So hopefully that's no real shocker here. Now, where the rub is we gotta worry about these guys here. So we're gonna plug in. I don't want to have to plug in for 3 of them for the little q's. So what I'm gonna do is I'm gonna come over here and I'm gonna solve this for big Q. So big Q is going to equal 4 little q over square root of 2. All right, so we're gonna plug that in over here. So big Q is going to equal 4 little q over square root of 2 times little q. Oh, this should be a minus because we're these forces are opposite. It doesn't matter which one's opposite, but we'll switch them to a minus. And then what's left over here? We've got square root of 2 over 2 times 2 in the denominator over little q squared equals 0. So what do we got over here? We've got 4 over root 2 q squared minus root 2 over 4 q squared, and that's not equal to 0. Good old math. All right. That's all we got to do for that. Determine the electric field at the center of the square. Okay, so we're looking at the square. We're looking at that spot right about there. So how do you calculate the electric field? The electric field is going to equal your force divided by your Q, right? Do you remember that? Hopefully. Now, your force is using Coulomb's law. So we're going to get a KQ over R squared. All right. Now there's there's 4 charges here, right? You've got little q on 2 corners and big Q on 2 corners. Well, if you were a particular charge here, let's pretend you're positive, because we always do. You're attracted to that way, you're attracted to that way, and you're repulsed by those other 2. So it's all going to cancel out because it's a square. E is equal to 0 newtons per coulomb. Nice. And that's it. Good old symmetry saves the day. Let's do the second one. 2 charges, plus Q and plus 2Q, are fixed in place along the y-axis of an XY coordinate system as shown in the beautiful figure below. Charge 1 is at 0, A, and charge 2 is at that point, whatever. Find the electric force, magnitude, and direction felt by charge 1 due to charge 2. Okay, well, let's figure out the force on charge 1. So we have a formula for that. F is equal to Coulomb's law, right? K times Q1. Q1 is just Q. Q2 is going to be double that. So let's put a 2Q divided by R squared. What's the radius here? What's the distance here? It's going to be 3A. And that's going to be squared. All right. So let's simplify this a little bit. So we're going to have K Q squared over A squared. We're going to have a 2 over 9. So 2 over 9 KQ squared over A squared. So wonderful. Oh, and then direction. This is going to be pushed up. Up. Okay. Find the electric field magnitude and direction at the origin. So we're looking for the field here. So there's two charges. We'll have to add together the two electric fields. So just like we talked, changed colors here. Just like we talked about a little while ago, your electrical field is going to be force over charge, which is going to give you a KQ over R squared. Now, there's two of these, so we're going to have to add up two of these formulas here. So let's do the top one first. So we're going to have a KQ over A squared. And then we're going to have to add it to, but they're going to be going opposite ways because one is pushing this way, one is pushing that way. So we're going to subtract, really, of a K2Q over 2A squared. And then that's in parentheses. Okay, so let's simplify this a little bit because we can. So this one is going to be a KQ over A squared minus K. We're going to have the 2 and the AQ A squared, and the 2 and the 2 squared is going to be a 1/2. That minus that is going to equal 1/2 KQ over A squared. So wonderful. So that is the electric field. That's the magnitude. What's the direction going to be? Well, the direction is going to be down. The direction is down because this guy has a stronger field presence there, right? Because this was from the top one and that's bigger. So is there a point on the x-axis where the total electric field is equal to 0? If so, where? If not, explain briefly. Well, these guys are repelling each other, right? So is there going to be a point on the x where they cancel out? No, there is not. The reason why there is not is because, remember, let's draw the electric field just in brief here. So remember, these are both pushing away. So they are going to be pushing away something like this, something like that, something like that, something like that. So is there a point where these guys don't have an arrow? No, not unless you're infinitely far away and you don't count that. They're looking for this spot right there. Okay, that's what they're looking for. And because if we look at the next question, is there a point on the y-axis where the field is 0? Yeah, you betcha. It's going to be this spot right there. So I don't know what the coordinates are yet, but we can figure that out. We just need to know where the two fields are equal to each other. Okay, so we are going to have KQ over R squared is equal to KQ over R squared, right? KQ over R squared. Let's plug in the specifics. Let's cancel out the K's. We don't need those anymore. So let's plug in the specifics. This is going to be a Q over, we'll call, what do you want to call this distance? I'm going to call it, just call it R. So that's R. And that's going to, whoops, I'm in the wrong guy here. So I don't want that one to be R, I want the top one to be R. It doesn't matter at all, but to be consistent. So now for this distance right here, what's this distance going to be? This is going to be 3a minus r, because it's the whole thing, take away that chunk there. So we're going to have 2q, because that's got a bigger charge, and this is going to be 3a minus r squared. Okay, I don't know if you remember how to do this, but you can FOIL it out if you want, but you don't want to. What you want to do instead is cancel out those q's, first of all, and just square root. Okay, we're going to square root the whole thing. So we have 1 over r is going to equal square root of 2 over 3a minus r. All right, this is the same. Now, plus or minus, if you really wanted to get to it here. But because there is another, no, there isn't. Okay, there isn't another solution. So what we have over here, so now crisscross multiply sauce. So we're going to get 3a minus r is equal to root 2r. So solving for r's, we're going to have them jump back over here. 3a is equal to root 2r plus r. So 3a is equal to square root 2 plus 1, parenthesis r. So r is equal to 3a divided by root 2 plus 1. Okay, is there a point? If so, where? So let's state the point. So the point is 0, 3a over root 2 plus 1. But here's the deal. You have to be careful. You have to be careful because that's going to be a negative. It's negative because it's going to be below. We didn't worry too much about it here. But that's what it is. Right? Because we know it's not 0 at the purple spot. And we know it's being pushed downward, so it's got to be below the purple spot. Okay, does that help for continuity? All right, looking at the last one here, let's get a new color. We'll go green. That's the hip thing these days, right? A small negative charge of negative q mass m, so you get like an electron, right? Were placed at the origin. Describe its initial acceleration. Okay, that's not too bad because we figured out the electric field there. All right, so you got to remember your electric field is equal to your force per charge. So we're going to solve for force. That means your force is equal to your electric field times Q. Your electric field was 1/2 kq over a squared. I'm going to clean it up a little bit. Kq squared over 2a squared, right? Times q, which is just going to be in the little q right there. So that's the force. Well, and how do you figure out the acceleration? You're just going to divide by m. So, because F is equal to ma, you've ever heard of that one. So kq squared q, little q, divided by 2a squared m. And that's it for that. Hope you had as much fun as I did. Like and subscribe, ring that bell to see the next video.